Welcome students. Today we are going to discuss a new topic, that is our Coulomb's law in chapter 1. So 12th standard CBSE chapter 1 we know electric field and charges. This is very important chapter we know basically. From first chapter electric charges and fields, in this chapter basically we have to know what is the meaning of this chapter. It is completely electrostatics. So what is meant by electrostatics? The charges is at rest. So the charges is at rest in a conductor in a normal field is called electrostatics. So in this electrostatics we have broadly classified into two types. So first chapter we are going to discuss here as electric charges and fields. Okay, from which we are going to do numericals, because the numericals a major vital role play in our CBSE or NCERT. So here I am going to take the first problem. So this is based on Coulomb's law. The Coulomb's law is the major important problem in our chapter 1. All of them know very well, I think so. So here what's the question we are going to discuss here? A free pitch ball A of 8 gram carries a positive charge of 5 into 10 to the power of minus 8 Coulomb. What must be the nature and magnitude of charge that should be given to a second pitch ball B fixed at 5 centimeter below the former ball so that the upper ball is stationary? The question they given very clear. First we have to read the question 1 or 2 times, then only we can able to attend the answers. Okay, first we have to know what are the data we have to write. Okay, so I'll write the data. First I am going to write the data of the problem. You have to know what are the data are there in this problem. First they given 8 gram. So 8 gram is nothing but contains mass. So we have to put mass M is equal to 8 gram. Okay, so 8 gram it is converted into 1 kilogram. You know all those things we studied in 11th standard. Everything should be converted into an MKS system, meter, kilogram, second. So gram we have to convert it into kilogram. What we have to put? M is equal to 8 into 10 to the power of minus 3 gram. So I am converted into 1 kilogram. First, any problem, first write the data. Data is very, very important. So this is the mass they given. Carries a positive charge. What the positive charge they given? 5 into 10 to the power of minus 8 Coulomb. So charge symbol you know very well, Q. Charge symbol is Q. So what the charge they given? 5 into 10 to the power of minus 8 Coulomb. So they given us charge Q also. So mass given, charge given. They are telling to find out what must be the nature and magnitude of charge that should be given to a second pitch ball B. The distance between the two balls they given us 5 centimeter. Distance we are known as R. 5 centimeter. So we have to convert into 1 meter. So what to put? R is equal to 5 into 10 to the power of minus 2 meter. Students listen carefully. Anything as length, mass, time, we have to convert it into 1 mass as kilogram, time as second, length as meter. So here I am centimeter, I am converting into 1 meter. So 5 into 10 to the power of minus 2 meter. So first data is everything we written very clearly. So for this is the data. Now we have to go to the concept. What they given in the problem we have to understand. They are given very clearly that we have 2 balls. This is ball A, another is ball B. Both are nothing but a free pitch ball. So what is nothing but here the free pitch ball? This mass contains of the first ball M1 is equal to 8 gram. Okay, so they don't bother about mass too, no problem. So okay, what they given? The positive charge of 5 into 10 to the power minus 8 Coulomb, that will be impact with the second ball. So ball A is going to be impact with, that is collide with the second ball, and finally the second ball have to move to the ball A, and finally ball A should be at stationary. Stationary means you know very well it is rest. Stationary means is nothing but what? Rest. So how the distance between the two ball A and B they given very clearly as R is equal to 5 centimeter. R is equal to 5 centimeter they given very clearly. Okay, charge also they given, total charge is 5 into 10 to the power minus 8 Coulomb. Mass they given. So what they are telling to here is to find out is the magnitude of the charge. That means you have to find out this second ball charge Q2. We need to find out here is the second ball charge. So ball A is there, ball B is here. when the ball is impacted with the second ball and finally come back to the initial position ball A at stationary, it should be at rest. What they are telling, how much amount of charge will be stored in the ball B, that we have to find out. So when you have charges distance means definitely we will go to Coulomb's law, we know very well. So we have to know the formula for this problem. Formula. What is the formula for this problem? F is equal to K Q1 Q2 by R square. F is equal to K Q1 Q2 by R square. This is the Coulomb's law formula. So this is the formula we are going to do. Next we are going to see the solution. Now we are going to go for solution. So we have written everything very clearly. Data, concept, formula. Next we are going to do solution. Okay. But we know constant K value, everything is okay. But what we are going to instead of force, we don't have force. But how we are going to find out force here? According to Newton's second law, F is equal to ma. The ball, A ball is acting towards the downward. When acceleration acting downward direction, then it becomes acceleration equal to acceleration due to gravity. Then what do we have to put here? We know very well. A equal to G. Then F is equal to what? mg. We have to know this formula very well. Now substitute in the formula, general formula. mg is equal to K Q1 Q2 by R square. So this is the formula. So now from this we are going to find out the, what we have to find out the second ball B charge Q2. Okay. So listen, Q2 is equal to what we have to find out here? mg R square by K Q1. So from this formula I derived and find out the Q2 charge ball B formula. That is mg equal to K Q1 Q2 by R square. We need to find out ball 2 second charge. Q2 is equal to cross multiply mg R square by K into Q1. Now we can substitute the values of this problem. Q2 equal to, what is m they given? 8 into 10 to the power of minus 3 into G value 9.8. Already we studied in 10th, 11th and 12th. Distance R, they given us 5 into 10 to the power minus 2 the whole square divided by K value 9 into 10 to the power 9 constant. 9 into 10 to the power of 9. What is Q1 they given? Q1, that is first charge. 5 into 10 to the power of minus 8. So everything we written. Now we have to do the mathematical calculation. Okay. First we do the calculation here. So first elaborate this one. 5 square is 25 into 8 into 9.8. First we will take the numerical value, then we will do the powers. 10 to the power minus 3, 10 to the power minus 2, the whole square will become 10 to the power minus 4. This is 10 to the power minus 3. So minus 3 minus 4 will give 10 to the power minus 7. This is in the numerator. Denominator like that we have to do. 9 5s are 45 into 9 minus 8, 10 to the power 1. Okay. Next, first we will simplify the powers, then we will do the values, numerical value. Minus 7 plus 1. The plus 1 will go to upward means it will become as minus 1. Minus 1 into minus 7, minus 8. So we found out here as 10 to the power minus 8. Unit of charge is Coulomb. Now we have to do normal mathematical calculation. 25 into 8 is a 200. 200 into 9.8. We got to do calculation. 200 into 9.8. You know normal calculation. 8 2s are 16 into 9 0s are 0. 9 2s are 18. Okay, now just do the multiplication. 0 0 6 9 1. 19600 is coming, multiply. So this is 9.8. So we have to keep one decimal ahead from this point. So we have to make a point here. So what are we getting? answer 1960.0. This is 1960. This is the value of numerator 1960. Okay, totally I am just telling. Divided by 45. Divided by 45. What you will get here as answer? 1960 divided by 45. What times it will come? For example, 45 3 sir, 45 4 sir, it will come as 180. Put 180 here, you will get a 16 and finally it becomes 0. How many times it will go? 160, 3 times. For 135, it becomes 25. So we have to put this 0 and make us a decimal here. And how many times it will go? Same 5 times. It becomes 235 and 25 will come and finally put us 5 and it will go like this 43.55555. When we make this round of this value, we can keep us, as per significant figure studied in 11th, we can keep us 43.6. So answer is 43.6 into 10 to the power of minus 8 Coulomb. So this is the answer of the problem. So this is all mathematical calculation what we did here. Okay, so finally we'll get this 25 and if we put this remaining means it will go like this. So I'm making rounding of this value 43.555, I'm making as 43.6 into 10 to the power of minus 8 Coulomb. This is charge 2. So this is the solution of this problem. Very easy problem. So first understand the questions one time and two time. First write the data and do the concept here, how to do the problem, what are the things are present here. Then you got to do the formula. This is a step of doing the numerical. Then you can easily attempt the numerical problem very easily. This is very important problem, and moreover this is a Coulomb's law based concept. First numerical problem we are doing now. So I did the solution here. So you can rewind this and you can note it down and do all the calculation. Finally we get the charge answer. Q2 equal to 43.6 into 10 to the power of minus 8 Coulomb. Okay students, so this is the answer for this first problem. So upcoming problems we will see on next video. Thank you.